All right, section 4.3, we're going to start with our triangle congruence theorems. This is not in your notes. I just want you to follow along here, okay? What I'm going to start with first is a triangle congruent statement. So off to the side of your notes, I want you to write triangle congruent statement. Okay, what this statement is it tells you what triangle is congruent to what triangle. So if I use these two as an example, and please write this down, you don't have to draw the picture, but if I say that triangle RST is congruent to triangle XYZ, okay, that right there is a triangle congruent statement, okay? If I take the picture away and all we're looking at is just that statement, okay, that can still tell us a lot about the triangle. Okay, so let's break this apart a little bit. If I ask you what angle R is congruent to, just by looking at that triangle congruent statement, what is it congruent to? Say it louder. Angle X. Okay, why did you say that? They're in the same spot, right? Angle R is congruent to angle X. Okay, what is angle S congruent to? Angle Y, again, they're in the same spot. And then last one, what is angle T congruent to? Angle Z. Okay, so the triangle congruent statement can tell us which angles are congruent to each other based on the order that they fall in. Capiche? Okay, along with the angles in the congruent statement, we can also say about the sides. So if I talk about side RS, what is RS congruent to? YXY. Yep. They're in the same spot, right? RS is congruent to XY because they're in the same spot. Okay. What if I said ST? What is ST congruent to? YZ. Okay. And then last one, if I can say RT, what is RT congruent to? Yeah, RT is congruent to XZ. So just by being given the triangle congruent statement, we can say all of those things are true without even having the picture next to us. Okay. However, the picture can be handy, but what comes with the picture is the theorems. Okay, so the first theorem we're going to talk about is side angle side. Okay, so what this means, does this side here have a congruent side on this triangle? Yes, so a side is satisfied there. Okay. Does this angle here have a congruent angle, similar placement on the other triangle? Yes. Okay, so I can label that as my angle. That is still satisfied. Okay, do I have another side on the other side of that angle that is congruent? Do you agree I have these two? Okay, so that side is also satisfied. Okay, so we just satisfied that these two triangles are congruent by side angle side. Okay, we're going to look at another example. Let's look at your example 1. Okay, here's your example 1. The only triangle congruent statement that we've talked about so far is side angle side. Okay, so ignoring the directions here, I just want to know if it is congruent or not. So let's check if it has side angle side. Does this side here have a congruent side on the other triangle? Is there a pair? Yes. Okay, so I'm just going to put an S there. And if I'm checking side angle side, I have this checked. Okay, so we have one side checked. Do I have an angle connected to that side? That's marked, right? Does this angle have a corresponding angle on this one? Yes, so that is, checks our angle. Okay, now do I have a side connected to that angle? Another pair. Yes, here. Okay, so these two triangles are congruent by side angle side. So if I asked you, are two triangles congruent? The way you would answer this is yes, because of side angle side. So this is your answer. This is your reason. Okay. I'm going to give you another example to look at right below this. So go ahead and draw this for me. If I give you this here. Okay, go ahead and draw those two, and I'll zoom in here for you. Okay, talk in your groups and ask yourselves, do these two triangles satisfy the congruence theorem side angle side? Talk in your groups. All right, what'd you guys come up with? Do these two triangles satisfy the congruence theorem side angle side?
No.
Raise your hand if you think no. Raise your hand if you think yes. Okay, everyone had their hand up for no. Why? Does anyone want to be brave enough to explain why they say no? Liam.
There's a right angle on the first one, and the second one isn't a right angle.
Okay, I agree with that. Don't worry about too much if they are right angles or not. Okay, but keep going with your thought because you say they're not the same angle. Okay, does anyone else want to try and explain? Cooper.
One, like, on that side has a right angle. It's like it meets at a 90-degree angle, and one's going straight and the one meets it. Whereas one on this side that doesn't have the right angle, they're both going up. Like, they're both not. Like, I don't know.
I think you and Liam are on the same track, which isn't a wrong track. Does anyone else want to try? Gage.
One of them connects the two, the other one doesn't.
Connects the two what?
Connects the 2 points.
Do you mean the sides?
Yeah.
Yes, okay. So with this side angle side, let's check. Does this side have a corresponding side on the other one? Yes, it has a congruent side, so we can check off that one of the sides is correct. Does this angle have a corresponding angle on the other side? Does it have a congruence marking? Yes, okay. Is there another side? Yes. I'm going to ask you the difference between these, though. Here I have side angle side. Here I have angle side side. What's wrong with those?
It doesn't connect the side.
And we're going to talk about what that just spelled in a second.
And the A is in between the S's.
Right. What I need you to take note of right now is that order matters. Okay, so we cannot jump around the triangle and say, yep, I see two sides in an angle, we're good with side angle side. Okay, to fix, do you agree this triangle is good?
Yep.
With side angle side. Okay, where would this angle have to be to satisfy this theorem?
And right,
It would have to be right here, right? If the angle was here, would this satisfy side angle side?
Yes.
Yes. Okay, but biggest thing, order matters. We will come back to this in a second. These 3 letters. We will come back to that in a couple days. Okay? All right, this is not in your notes, but I do want to talk about this real quick. Notice how that dotted line is on both triangles. What it's trying to say is that these two triangles came from a rectangle. So that dotted line, is coming from right here. So at one point in time, those two triangles were connected to each other. Okay, so what can we assume about these two sides then if they were once connected? That they're the same, right? So I can assume, since those were at one point in time connected, that they are the same, okay? Here's another example that we will see in a second, okay? But bear with my drawing here. Are these two triangles connected? What are they connected by? A vertex, right? What do we know about these two angles on the other side of those vertex? That they're equal, right? So another thing, we can assume that if they were connected by a vertex, we can assume that those two angles are the same. Okay, so go ahead and write this off to the side of example 2. If two triangles are connected by a side or a vertex, you can assume the side or angles are congruent. This is the only piece using these theorems that you can assume. Okay, you can only assume if they are connected. Okay, if they are not connected, you can now just start putting congruent signs in the triangles and be like, yep, I made it congruent. It's true that they're congruent. Okay, they have to be connected, and those are the only 2 ways shown up there that they can be connected. Okay, they can be connected by sides or they can be connected by a vertex. Okay, all right. This is your example 2. Ignoring all of the words here. Okay, just looking at that image, are the two triangles connected?
Yes.
What are they connected by?
Side.
They're connected by a side. Everyone see this side here? So what can I assume about that connected side? That it's the same. Okay, so I can mark that that side is the same. Okay, I could draw it as 2 separate triangles, but are we going to want to do that every time? No, that's annoying. Okay, so we're going to keep them together, still noting that this side is the same. Okay, we also know that this side is the same, yes? What do these arrows mean? They're parallel. Make a note that the arrows, parallel. Those arrows mean that they are parallel. To satisfy side angle side, what are we missing? We're missing an angle. Do those parallel lines help us know what angle is congruent? I know it's been a while. Okay, what is this line called that goes through the parallel lines? Transversal line. Go ahead and make that note there. That is our transversal line. So, remember alternate exterior, alternate interior, all of those, same side interior, those. Okay. Does that help us here? Okay, what can I say about these two angles here? Yeah, they're the same because those are alternate interior angles. So we can assume that those are the same. Did that just help us satisfy side angle side? Yes, okay, because again, we have a side angle side on both triangles. Are they in the correct order? Yes, so we can say, yes, these two triangles are congruent by side angle side. Okay. Now, the question that this example had was, how can we say, or how can we show that angle B is congruent to angle D? So how can we say these two angles are congruent to each other? Didn't we already say the two triangles are congruent because of side angle side? So if we already know the two triangles are congruent to each other, can we assume that these two angles are also congruent to each other? Yes. Okay, we can say that because we already proved that they are in fact congruent to each other. So that would make everything else that's not marked automatically congruent to the other side. Okay, so we can also assume that AD is congruent to what? BC. Okay, so again, once you say that they are congruent to each other, you can automatically say that everything else is the exact same also. Okay, I'm going to challenge you here real quick. Go ahead and try and write a congruent statement for those two triangles. So go ahead and try and write your congruent statement for those two triangles. I'll get you started here. Okay, here's triangle 1, here's triangle 2. Okay, remember a congruent statement is I'm talking about triangle ABC is congruent to triangle. You want to find the right order for this side. This one can get a little confusing because they are overlapped, okay, or they're connected. What angle is congruent to A? It is C. Yep, triangle C. What is congruent to angle B? D. What is congruent to angle C? A. Okay. What's a little weird about the overlapping or shared triangles is that usually you would think A should be congruent to A, right? But notice that they are sharing two different angles because they are a part of two different triangles. Okay, so this would be your congruent statement for this one. Okay. All right, so we have talked about one theorem already, side angle side. Now we are going to talk about what's going to end up being your favorite, side, side, side.
Why?
Okay, I will explain why in a second. So looking at this diagram here, you do not have to take notes on this, but does this side have a corresponding congruent side on this one? Yes. Okay, do the other two sides also have that?
Yep.
Okay, why do you think we can say these two triangles are congruent to each other? Just because all the sides are the same? If the sides are the same, the angles have to be the same. Make that note. Off to the side. Go ahead and write side, side, side. If all sides are the same, all angles must be the same. Because remember, when I had you make an angle with your hands, okay, when we're changing that angle length or that angle measure, we're also changing that side length. Okay, so whatever that angle measure is, if I had me and Gage make the same exact angle with our hands, our two sides would have to be the exact same. Yes? Okay, so that is why this theorem works. Okay, so side, side, side is our other theorem today. If you see that all three sides are congruent, then you can assume that they are congruent to each other. The two triangles are. Okay, so let's go ahead and look at example 3 here. Are those two triangles congruent to each other? Yes, why? What's the theorem? Side, side, side. Yep, remember when you're answering these, you say yes or no, and then why. Okay, so yes, they are congruent because of side, side, side. All right, for a triangle congruent statement, what did you guys come up with? I'm going to ask this real quick. Does it matter how I order the first one?
No.
No, someone give me a random one.
PQR.
PQR. Did every one of you put PQR?
No.
No. Is it okay that you didn't?
No.
Yes.
It is okay. Okay, we will get different answers, but should they still end up being the exact same in some way? Yes. Okay, so if we continue with this one, do we know anything about the angles here? Do we know anything about the angles in these two triangles? Just looking at it, no, but can we figure it out? Yes. What angle is going to be congruent to P? S. What's going to be congruent to Q? T. What's going to be congruent to R? U. Okay. You could have also had this written as QRP is congruent to TUS. Could I have also had it written a different way? Yes, I could have had R. Sure. QP is congruent to UTS. You could have had this written multiple different ways. Okay, but again, do all three of these and any other ones that you had all say the same thing? Yes. I want you to try example 4, A and B. Let's take a look at these here. On part A, are those two triangles congruent to each other? Clap once if you agree with yes. Why are these two triangles congruent to each other? Because we can't just say yes, we got to prove it. It is side, angle, side. Okay, again, we need our answer and then our reasoning. Okay, this is good enough for your reasoning. You don't have to say, well, there's a side here, there's an angle here, side here. Just say side, angle, side. Okay. Again, does order matter? Yes. Okay, this satisfies the order, so we're good there. What about part B? I heard no. Clap once if you agree with no.
That was pretty clever.
Does anyone say yes? Clap once if you agree with yes. It's no. It is no. Okay, why is this no?
Because it's the other word.
Where does the angle have to be? Give me the letter. Where does the angle have to be? Has to be F and J. Remember, order matters, okay? I can't jump around the triangle and be like, yep, side, angle, side. I cannot jump around. Okay, that angle, if it satisfied side, angle, side, that angle would have to be in the middle of the two congruent sides to satisfy side, angle, side. Okay, so this would be no. You will have questions that say what can make this true. Okay, and what can make it true is just by saying angle F is congruent to angle J. Okay. If we had that information, then we could assume those two triangles are congruent to each other. Okay? Yes, sir.
Is that
And then what
is
do we
that
put for the reason?
It's supposed to be a J. What?
It looks like a wonky S.
So then what would we put for the reasoning if we can't put that word on our paper? Because you put no and then there's.
Oh, I get it. Usually if you put no, like that's enough reasoning in itself. But if it asks you to make the statement true for a certain theorem, this would be your reasoning about how we could make it true.
Okay.
Okay, good question. Let's practice this again. On part A, let's make a triangle congruent statement. So on part A, what is a, how can I start it? TSU is congruent to triangle.
YXC.
It is YXZ. Again, can I just put random letters together and call it a congruent statement? No, they have to be in order, corresponding to each other. All right, looking at example 2 here, the error analysis. Elijah says that those two triangles are congruent to each other by side angle side. Explain his error.
Whoa. F and C are not congruent.
Right. How else can I explain that? Because I agree, these congruent markings don't match up. What would angle A have to be congruent to?
D.
It would have to be congruent to angle D. Okay, so just a little note I want you to make here. Again, order matters. Okay, on number 4, what theorem can prove that those two triangles are congruent to each other? On number 4. Side, side, side. Yep, those two triangles are congruent by the theorem side, side, side. Okay, and then example 5 here, I'm going to zoom in a little bit. We talked about this very briefly, okay? Are those two triangles connected? What are they connected by? A vertex. What can we assume then since they're connected by that vertex? These angles are the same, right? In the directions, it tells you that these two lines right here bisect each other. What does that mean? Split in half. Yep. So if JK bisects LM, what happens is that these two become equal to each other because they're split in half. Okay. And then vice versa, LM bisects JK. So what do we know about the two sides of JK? They are the same. So can we say that triangle 1 is congruent to triangle 2? Why? Side angle side. Bingo. Yep. So remember, the only things you can assume is if they are connected to each other. Okay, I got these two based off of the directions that they gave you. Okay. All right. Number 6 through 8, you are saying if the triangles are congruent and by which theorem. Okay, so on number 6, are those two triangles congruent?
Yes.
Yes. Why?
SSS.
Side, side, side. Okay. Clap once if you agree with that. All right. What about number 7?
No. Yes.
Yes.
All right. Here's what I want. Clap yes, or clap once if you agree with yes. Clap once if you agree with no. Okay. No wins. No is correct. Why no? Who's brave? Eliza. The markings don't match up, right? Is there a congruent symbol that matches this one on the other triangle? No. So that would be no.
In my defense, I looked at this maniac, he had yes, so I put yes.
Do not blame this on me.
All right, number 8. Yes or no?
Yes.
Yes.
Clap once if you agree with yes. Why yes?
Because it's same, or not same,
Side, angle, side. Good. All right, number 9 through 11. Okay, do you agree these triangles are connected in some way?
Yep.
Yes.
Okay. On number 9, what are they connected by?
Vertex.
Oh.
They're connected by a vertex.
No.
Okay, so what can I assume since they're connected by that vertex? The angles are the same. Okay, are those two triangles congruent? Clap once if you agree with no. Clap once if you say yes. Okay, the answer is no. Why?
Wait,
Because
don't B and E
Order
have to be the
matters.
same.
Remember, make a note. Order matters.
Don't B and E
was
have to be the
congruent to
same?
E. Or
Yeah.
if B was congruent to E.
Right, if I agree with you there. If B was congruent to E, then it would work by side angle side. Okay. What about number 10? Are those two triangles connected? By what?
A line. A
This
congruent line.
side, right? So what can I say about that side?
It's wrong.
It's the same. So are these two triangles congruent? Yes. Why? Side, side, side. Yep. Can I just randomly put, okay, M and P are congruent, so that's side angle side? No, you cannot. The only thing that you can assume is what they're connected by. Yes.
But you said if they're connected by that, then you can just, then
Okay.
you assume that the angles are the same.
After the fact, yes. So after the fact, since we said they're congruent, then we can assume all of these other things are the same. Yes. Okay. Number 11 is a little tricky. Are those two triangles connected?
Yes.
They are. Okay, they're connected by this little random side in between there. But can I assume these two angles are the same? No, because those two angles themselves are not connected. Okay? What other piece of information do we have in that picture? The parallel lines. What do those parallel lines help me with? Congruent angles. Okay, remember this is our transversal. What angles can we assume are congruent? These right here. Yep. So are these two triangles congruent? Yes, because side, angle, side. So another thing you can assume. When they're connected, assume by whatever they're connected by. And remember, keep in mind the parallel lines and all the angle measurements that you can assume. Okay?